theta d0.
Good ideas.
So in 9.2, number 37, I want to find out when is tangent of 2 theta plus tangent of theta equal to 0. Yeah, never would be an option. So it's possible that there's no solution to this equation. I think this equation has at least one solution that I can eyeball straight off the bat.
0.
Which is, yeah, probably theta 0. So how could I, like...
So tangent of 0, 2, yeah, tangent of 2, 0 plus tangent of 0.
Yeah, so that would be tangent of 0 plus tangent of 0, and tangent of 0 is conveniently 0. So 0 plus 0 is indeed 0. So at the very least, I can check that one off.
Pretty simple.
What about an angle that's negative? So because negative multiplied by a negative is a positive, so you can have a positive plus its negative, which would get you a 0. Maybe, I don't know. But you can't.
Yeah, like.
But you can't double something and then make it the same as. Never mind. I don't know.
You'd have
I was trying to.
No. That was actually a valid point, though, right? So I'm trying to solve this equation, right? I've got two things added together are 0.
Yeah.
So there are kind of two options for that, right? Either they're both 0,
right. Or one's positive one.
or one's positive and the other one's negative that thing. You see that? So I think that they're both 0 would be this guy and maybe pi. I think pi works. Why would pi work?
2 pi, and then
Because the slope of the flat line
Yeah.
is 0, and pi is 0.
Okay, so I could think theta is pi, because then the two angles we're talking about, right? And here we have 2 pi,
and
which
then
has a tangent of 0.
Mhm.
And in here we have
pi.
pi, which also has a tangent of 0.
Yeah.
Okay, so at the very least that one works.
Okay.
That's still in that 0 plus 0 equals 0 kind of case, right?
Mm-hmm.
And then what else should I do with these guys?
Or add plus k or whatever.
Yeah, I might think like add 2 pi k,
Yeah.
right? Because
It only wants.
does it only want ones
it
in
only
the
wants
unit
theta
circle?
Theta between 0 and 2 pi.
Oh.
Oh, cool.
But I
So
think-
0 is smaller than theta is smaller than 2 pi?
Yeah,
Okay, well at least I found 2.
I think 2 pi will work as well.
Oh, and 2 pi works. That would be me thinking about adding 2 pi k to this guy,
Right.
right? So how do I know 2 pi works without spending too much time checking?
Because you know 0 works.
Yeah, because 0 works and it's co-terminal with 0, right? Okay, what else? So maybe you'd think this way. You'd be like, tangent of 2 theta is minus tangent of theta.
Yeah.
Okay, another thought you could have, like maybe a good one. Graph this. What's the tangent function look like?
It has asymptotes at 90 and 270.
Okay, so there's asymptotes at
Negative pi over 2 and pi over 2.
negative pi over 2 and pi over 2.
And it's
And
270.
infinitely receding into pi over 2.
Pi, 3 pi over 2.
Negative pi over 2.
okay, hang on. First, where's this other asymptote?
3 pi over 2.
That's at 3 pi over 2.
And then negative 3 pi over 2.
And then, yeah, there's more stuff on the negative side, but I don't care about that stuff because they ask me to find angles between 0 and pi over 2. Or, sorry, 0 and 2 pi, right?
Yeah.
Okay, so tangent in here looks like this kind of thing.
Yeah, same thing.
And then the same thing repeating, this kind of thing. And then the same thing repeating this kind of thing. That one's at 2 pi, right?
Should be.
And really, I don't care about the negative stuff, and I don't care about anything bigger than 2 pi. Right? So really, this is the world I care about right now.
That's pretty cool.
And this is, the black stuff is tangent theta, right?
Mm-hmm.
With me on that?
Or second part.
Okay, so if I rearrange this into maybe this way, that black picture would make sense.
Yeah.
Because tan is an odd function, right? Does that mean if you have tan of 2
Nice.
theta equals negative tan of theta, that means tan of theta is equal to positive tan of theta? Or do I have odd and even mixed up?
I think you're getting ambitious with odd and even. So what odd would tell me is that I could pull this sign in here,
And it would equal tangent.
right? So I could have negative tangent of 2 theta is tangent of negative 2 theta. Or I could have pulled it into the other side.
So an odd function is f of x equals negative f of x, or is that an even function?
That's an even function.
Okay, an odd function is f of negative x equals negative f of x.
Yes. Yeah, so an odd function, you can pull minus signs from the inside out or from the outside in.
Even function is f of
And
x
even
equals
functions
f
mean that you
negative
can
x.
discard a minus sign in the parentheses.
Yeah, that's what I thought.
So
So if you,
I have this black part, right? What do I want to know that that's equal to?
the negative tangent of 2 theta.
This other thing? So I'm going to kind of suggest that this part be blue.
Flipped over and amplitude of 2.
Okay, so there's a vertical flip,
And
right?
then horizontal compression of 2.
So it looks like this picture except vertically flipped over and then horizontally compressed by a factor of 2, right?
So it's gonna
So I
be-
just need to redraw this picture in this space
Is it 60 degrees?
and
So-
upside down. So I'm going to have
Are the
2
asymptotes,
asymptotes in there.
are they
right?
still going to be the same? They're still going
And
to
they'll be,
asymptotes.
let's see, if I compress this picture by
2, so it's
2,
going to be pi.
then this is not going to be pi over 2 anymore, it's going to be pi over 4.
Or 4, I mean. So basically you're just
And-
shifting it over by a factor of 2.
So I'm taking this whole picture and smashing it in by a factor of 2, right? And then I'm drawing upside down. So I have this guy,
But what about the black asymptotes? So do you have to worry about
think-
that?
no,
No? Just
yeah,
just the
I'm
blues?
totally redrawing this picture.
Okay.
Right.
Right, so now I need this part flipped over and drawn in here. So that looks like this, I think.
Whoa, it's crazy.
You guys see that?
Yeah.
And then I need another one flipped over and drawn in between this and my next one's going to be here. And then there's going to be another one here. So I need another one flipped over and drawn in there. And another one flipped over and drawn in here.
Very nice.
And another one flipped over and drawn in here.
That's very nice.
Okay, so far I think I have intersections that are relatively obvious.
So they want to know when it's at 0.
So where are the intersections between blue and black?
0 at the origin.
Okay, there's one here,
There's another one at, what is that?
there's another one there,
Is that pi?
and there's another one there at least.
Those are all the ones you checked.
Right? Those are all the ones I knew about already, but you guys see any more?
If you
There's-
add a 0 to an asymptote, does that give you 0 or does that give you undefined?
Oh, that gives you undefined. So I'm asking where does the blue stuff, right? Blue stuff equal black stuff.
All the places where they.
Yeah, all the spots where blue stuff crosses black stuff, right? And solid stuff, not asymptotes, right?
Right.
So I got these ones because those are where they hit. Where else do they hit?
Past pi over 2.
No.
Yeah, just past pi over 2, like here.
What
Oh,
about-
and there's another one there.
There's another one.
And there's another one here,
Another one.
and another one there. You guys see that? So there's 4 more
So
that I haven't yet found. So how would I go about finding these using a graph? Like using this method, how could I go find those?
I have no idea.
If I put it on a graphing calculator, I'll be able to calculate intersections.
Yeah, we could at least get approximations out of a graphing calculator. You guys see that? So, do you guys want to do that, or do you want to try a different
That
method?
first one, the second red circle you have, the x value is approximately 1 point, it's really close to 1.047, and a bunch of other numbers. But
Okay, so x is approximately 1.047, and you're in radians,
and
right?
y,
And I don't care what the y is.
yeah, and radians.
Oh, and that's not an x, right? What is that?
Theta.
Yeah, perfect. That's a theta. Right? How about this guy? And then this guy, and that guy.
Well, the second one should be the same, shouldn't they?
Second
Well,
one,
sorry. It'll be.
yeah, you might think it's,
relatively the same. You'll just have, because it's just a periodic thing, so you just have to add a solid value to your theta.
my expectation is that at least this one, oh, that one does look a little different, doesn't it? I think that's just crap drawing on my part, though.
Yeah.
My guess is that this one is a shift of probably pi from this one.
I think that's a reasonable assumption.
But that's just a guess, right? Like, I'm just kind of guessing at this thing. The other one is probably not a straight up shift, although it might be. If it was a straight up shift, I would expect it to be a pi over 4 shift. You guys see that? My guess is at the very least the amount that that's above pi over 4 is the same amount that this is below 3 pi over 4. So I could use that and figure it out.
At the second bottom intersection, the theta would be 2.094.
Okay, sure. And then these other two you can calculate similarly, right? So this would be one approach you could take. Like, I know these 3 values, and then I'm approximating the other 4. What's another approach I could take? How else could I try to? You see another method? Because this isn't what they asked me to do. They asked me to use trig identities to
Yeah, I was
solve.
gonna say, can you set up to solve the equation for theta?
Yeah, I really kind of need to set up to somehow solve this equation for theta, right?
And then double.
You guys see that?
identities addition.
So my guess,
So theta plus theta.
at least a weird thing you could do, is you could use the fact that tangent's negative and make this into tangent of negative 2 theta equals tangent of theta, right? And that's because tangent is odd.
I thought that was the. Alright, never mind.
So odd means, right, that f of minus x is minus f of x.
Right.
So I took this backwards, right? I said, okay, if I have an odd function and a negative sign outside of it, that means I could bring it inside. Okay, see this? So I got this thing. And then I could take arctangent of both sides,
Watch now.
right?
Yeah.
So if I take arctangent of both sides, and these will, remember, arctangent's not an actual inverse, it's just a partial inverse. So this might be fraught with annoyance. But if I take arctangent of both sides, I would get minus 2 theta equals theta, right?
So then, so negative 2 theta is, what?
What?
So I
So,
get what you did, but like I don't get why this is this way.
why this is helping. Hang on a second.
So theta equals.
So if
half
you
of-
subtract theta from both sides, right?
Oh,
You get minus
theta equals 0.
Minus.
Wait, negative, negative 3 theta?
That's not
I got negative 3 theta is 0.
Yeah, it doesn't matter.
That seems like it would suggest theta is 0, right?
It does suggest theta.
Is that?
0 over negative 3.
So where's my other one?
And then divide by negative 3, so theta is 0.
Okay, so I took the arctangent of both sides, and what I'm running into is arctangent's not actually an inverse, right?
So do we just use,
Yeah, so another thing I could try is the double angle formula for tangent.
don't think we learned that? Did we learn that?
I didn't teach you that one, but we could figure it out.
Can't do it.
Why don't you, we can find an angle whose reference angle is the same in the double.
You want to make a separate video to show
No.
the tangent?
Joey had suggested we could
Probably.
do the sum angles identity of tangent as well, because it's 2 theta, so it could just be
Yeah,
theta plus.
so we could get the half angle identity for tangent, right, by doing the sum of angles identity.
Well, you said that, but yeah.
Okay. So
Levi's.
That's okay. No problem. Those are sources.
let's try this. Let's think about tangent of minus 2 theta as tangent of minus theta plus minus theta. Right? is tangent of theta.
Yeah.
And then we could use the sum of angles identity for tangent, which says what?
Tangent of minus theta plus tangent of minus theta over 1 minus tangent. That
Just say louder. Go.
Alright, so the tangent of minus theta minus the tangent of minus theta all over 1 plus tangent minus theta times tangent of minus theta. Yeah.
Okay. Cool.
Yep.
Nice.
That's so much fun.
All right. And this is supposed to equal
And
tangent of theta, right?
yep.
Okay, so then I could use some things about oddness, right? So I can pull this minus sign out. I can pull that minus sign out.
That's 0 on top.
This is tangent of theta minus theta squared, right?
Mm-hmm.
So if I pull that minus sign out here, and then think about squaring it, that minus sign doesn't matter at all. That's because tangent of minus theta is an even, or tangent of theta is an even function when after you square it. Oof, that was weird.
And then tangent squared of theta is.
So all told here, I think I got,
Wait, that's 0.
1 on top, or 0?
I think I got
If it's
0
zero,
on
if
the
it's 0
top
on the top, it doesn't even matter what you put on the bottom.
is bugger. Where are the other two solutions?
Can you do it?
Can you read me the identity wrong?
No?
Shouldn't it be 1 minus, or tangent theta plus tangent theta and minus? It should be a plus sign in the middle, not.
It should be a plus sign.
So that's
Did
where
I
you,
read
that's
you
where
the
you get.
difference? Oh yeah, I did.
I'd read
Okay.
What makes it different?
That should be a difference.
You're right.
I get it. It makes it different.
Adorable.
I thought that was a real laugh.
I thought that for a second, and then it was super.
And then
it was super.
and then it was
salty.
super condescending.
Yeah.
Okay, so you have minus 2 tangents of theta, which makes better sense.
It does.
Equals,
Makes a difference.
and then over there I have,
Tangent of
And
theta.
what about what happened at the bottom?
oh, okay, what happened at the bottom? So I have 1 plus tangent squared of theta
Yeah, which is like something.
equals tangent of theta, right?
Yeah.
Oh, this is going to do it for me. This will work perfectly. So then divide both sides by tangent, multiply both sides by 1 over tangent of theta, which is cotangent of theta, right?
Multiply both.
Can you
sides.
stick with 1 other tangent?
Yeah.
Yeah, please, that would
Multiply
help.
both sides by 1 over tangent.
So multiply both sides by 1 over tangent of theta.
Okay.
And now you'll get minus 2 tangent theta times 1 over tangent theta all over 1 plus tangent squared theta equals 1, right?
Yeah.
And then, oh, you might notice tangent theta times 1 over tangent theta is,
One
tangent.
is
Negative
one.
tangent.
It's gonna
One.
be
Oh, one. Okay.
1 negative
right?
1.
Those guys
It's
cancel?
gonna be negative half over.
Negative 2 over 1.
So I
Or,
think
yeah,
all
negative
told
2.
here I got,
Oh, no, that was a good try.
oh, I know, we needed those. Oh, well, they're gone now. We'll have to get them. So we got minus 2 over 1 plus tangent squared theta equals 1, right?
Yeah.
Is that negative?
So multiply across. Yep, minus 2 is 1 plus tangent squared of theta. Subtract 1. You get minus 3 is tangent squared of theta.
You can't square root of
Well, that's really annoying.
So then don't pull out your, leave your negative signs in your tangent.
Ah, damn it. I really wanted this to work perfectly, but I'm really running into problems with arctangent, aren't I?
Or what about the
Did we
negative
switch the
tangent?
sign on the top of the fraction? Did we switch the sign on the bottom of the fraction?
Switch the sign on the
Yeah,
top.
for the identity, they're both changed.
Oh, you dorked me?
I dorked you the first time, not the second time.
Is this one also supposed to be
That
minus?
one's also supposed to, well,
No, it should be the opposite sign.
so for the sum identity at the very beginning of it, it's positive on top, like the plus sign on top, and then a negative
But you're
sign on the
it's
bottom.
actually
Dude! Come on, man!
Didn't you undo that though?
No, I I fixed it on the top, but not on the bottom. You read me the difference of angles like
I did.
identity, and I let him because I don't know the this isn't your bet. This is all me. I don't actually know the sum of angles identity for tangent.
Well, there you go.
That's a thing I go look up in the book when I need it.
Yeah, it's like,
So I dorked it because I wasn't familiar. So that's supposed to be a minus sign,
So that's minus.
which if you chase all the way over here is going to be a minus sign over here.
There you go, now you can take the square root.
And now you'll get square root of 3 is tangent of theta. And you can arctangent that one by hand.
And
Right.
that
See the
would be
arctangent, yeah.
45.
So you're
No.
so you're in a 30, 60, 90 triangle, right?
You said 60 degrees away.
So
All
in a
right.
30, 60, 90 triangle, you have 1, 2, and the square root of 3.
That'll be tangent of.
And I'm looking for
60
tangent.
degrees.
This guy says.
It's 60 degrees.
So that would be up here.
No.
I think it's.
Well, yeah.
Yes. Which is 60 degrees. And so I think my thetas are,
Pi over 3.
so this should be a pi over 3, and then we could go figure out where the other ones are.
Jeez.
But is
no.
arctangent only partial? So like, is it like?
Yeah, arctangent's only a partial
So does that
inverse,
mean
so
it's
you
the-
need to
it's an
go
angle
find
whose
the other
reference is-
4.
So it's like an angle whose reference is pi over 3. Okay, because I think it's actually like 120 degrees. Right?
What do you mean it's actually 120?
Like, because if you double 60 degrees and it gets you 120, that's like negative for tangent for both. It's like, oh wait, no, that makes sense because if once you double the negative, it gets you a positive. It's cool.
120 degrees works.
So, yeah, they're pi over 3 and then kind of associated other arctangent bits.
Cool.
You guys all good with that? So those are going to be pi over 3 and then maybe 2 pi over 3 and kind of some others.
Cool.
And, yeah, 4 pi over 3 and 5 pi over 3 will be the other two.
thanks.
Cool. So we probably could have caught that a while back. When we got approximately 1.04 out of the calculator, we maybe should have thought to ourselves, hey, that one sounds a lot like pi over 3 to me.
How does 1.04 is on a pi over 3?
Oh.
Oh, because 3.14 divided by 3 is almost 1.
Yeah, like
I keep forgetting that pi is like...
pi over 3 is like 3 over 3, give or take, so you would expect that to be about a radian.